In the third unit, we are going to discuss a linked list. It's a one more type of data structure and trees. Especially, we are going to discuss with the binary tree. Once we have allocated the memory, we have to deallocate the memory. Why we have to deallocate the memory? Because the main memory is very short. The terminologies that comes with the another data structure like array, stack, queue, linked list is little different what we are using the terminologies in the tree. Hello everyone, welcome to the session or introduction part of the subject data structure using C. This is a particular subject for the second semester B.Ca students. Myself, Indu J, the Faculty of Computer Science Department, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. I welcome you all for this session. Data structure using C. First, we have to know what is data structure. We can divide our data structure into two categories. One is data and another is a structure. What is data? Anything that is related to the computer, we refer it as a data. Okay, how we are going to structure that particular data is called as data structures. When we are dealing with the database management system also, we are dealing with the data. When we are dealing with the big data, data analytics, everywhere, wherever you, whatever you take, it's purely the game of data. So, when we have a large amount of the data, we should structure or organize such data in proper way so that it can be easily accessible. For how to organize the data or how to structure the data within the computer main memory, that is what we are going to deal in this particular subject. Okay, hope all of you clear why this subject is important, because whenever we do any programming, any code, anything on the computer, everything has to be taken care by the CPU and in the main memory. Once you are not arranged properly the memory, it will be very tedious job to have anything. So, it is very important to arrange the data within the main memory in proper way. So, that is what introduction about data structure. Here in this particular subject, we are dealing with C programming language. How data has been organized using a C programming lab. Let us see what we are going to discuss. We are going to discuss about the syllabus, how many units we have, what all we are going to study in those particular units, and what is the learning outcome out of it. After completion of this particular subject, at the end of your semester, what are you going to carry with you as a data structure? That is nothing but a learning outcome, and how many number of units we have, then how the marks distribution will be for the internal as well as for exam, and how exam question paper pattern would be. This all we are going to discuss in today's session. Let's come to the syllabus. How many units we have in this? We have 3 units in this. Particularly dealing with different type of data structures. Each unit deal with a different types of data structure. In unit 1, we'll go with the introduction of data structures and introduction of functions, recursion, and then the simple introduction on array. In the unit 2, we'll continue the discussion of array with the another data structure called stack as well as a queue, which will be implemented in many field or many areas. In the third unit, we are going to discuss a linked list. It's a one more type of data structure and trees. Especially, we are going to discuss with the binary tree. Let's see what we have as a learning outcome. After completion of this particular subject, what you are going to carry with you. The first thing, after completion of this course, satisfactorily, the student will be able to describe how array, records, linked structure or linked list, stacks, queues and trees are represented in the memory. How these particular, each one of the data structure has been represented in our computer main memory, that you are going to understand, that you will understand once you complete this subject. Then describe the common application where all we can use this particular data structures, arrays, record, linked list, stacks, queues and trees, where all we can use, where we can implement these type of data structure, that you get the clear idea about that. Then writing a program using these data structures. When we have to apply it somewhere, you have to write the program, right? Once you are writing the program, you are applying it on the particular application. So writing the program using array, linked list, stack, queues and trees. After this, what you are going to understand is demonstrate the difference between the traversing, comparing the alternate implementation of data structure. If I cannot be able to implement particular concept using the array, in place of array, what I can use it as alternate data structure, that you will get the clear idea about what all the alternate data structure we can use and where we can use. Then describe the concept of recursion with the example. Recursion is nothing but calling the function itself. Function calling the function is called as recursion. What is recursion? Why we have to go for recursion? And what is the use of recursion? You are going to get a clear picture on this and discuss the computational efficiency of the principal algorithm of sorting, searching and hashing. What is sorting? Sorting means arranging in a proper way. Data has to be arranged in the proper way, that is called as sorting. Once data has been arranged in the proper way, it is easy to search, right? So searching, then it comes, then hashing. These are all the different concept what you are going to understand by studying this particular subject. Next, what we have is first unit as an introduction to data structure. What we are going to discuss in the unit 1. Basically, we will give the introduction. What is data structure? How many types of data structures are there? That, this and all. So let's see. Definition. What is data structure? That is a definition what you are giving for the definition. Type of data structure. There are two major categories of the data structure. One is primitive and one is non-primitive. So in that non-primitive, again we have subcategories called as linear and non-linear data structures. So we are going to discuss in detail as we are move with the sessions on data structure. Okay. Then apart from the type of data structure, we can check with the operation. What all the operation we can do on the data structures. That is, once we have done with the operation, then memory allocation, dynamic memory allocation. We have two types of memory allocation, static and then the dynamic. Here in this particular topic, we are mainly concentrated on dynamic memory allocations and difference between static and dynamic memory allocation. Memory allocation, and once we have allocated the memory, we have to deallocate the memory. Why we have to deallocate the memory? Because the main memory is very short. You have a large number of secondary storage memory, but when it comes to the main memory, random access memory, that is very small. So once we have used, we have to give it back. So that is what the concept of deallocation we deal with. So different functions what we have for the dynamic allocation, that is malloc, calloc, realloc and then the free. After discussing this, we are going to discuss about the algorithm specification, performance analysis of the algorithm and performance measurement in the algorithm. Then we come with the recursion. I have already told you what is recursion. Recursion is function calling itself many times. That is called as recursion. Definition, type of recursion, recursion techniques, how many recursion techniques we have and some of the examples on the recursion. Those examples are finding the GCD, finding the binomials, coefficients or Tower of Hanai problem. These are some of the examples what we solve using the recursion technique. Apart from this, in the module or unit 1, we have an introduction to array. What is array? The basic concepts array, definition, declaration, initialization of array, what all the operation we can do on array, type of array. We have different types of array: single dimensional, two dimensional and multi-dimensional array. That all we are going to discuss here in the module 1. In the module 2 or unit 2, we are going to continue the discussion on array, once insertion and deleting the element using array, sorting, selection sort, bubble sort, quick sort, selection sort, insertion sort and sequential search, binary search. These are all we are doing with the help of array. What we are, the main concept of data structure is sorting and searching. How the sorting and searching, there are different techniques of sorting and searching we are going to discuss using array, and we are going to discuss with the multi-dimensional array representation and where we are using this multi-dimensional array. Then in the stacks, what we are going to discuss, the stacks again comes in your unit 2. The stacks, we are going to discuss the basic concept, definition and the declaration, representation of the stack, operation, what all the operations we can do on the stack, then application of the stacks, where we can use a stack. We can use the stacks on infix, postfix and prefix conversion or notation. How to do the arithmetic evaluation or arithmetic calculation. Expression can be evaluated how? That is by using infix, postfix and prefix. Infix means we have a two operand in between the single operator. Postfix is nothing but two operator with a single operand, and then prefix means single operator which is preceding to the operators. That is what as prefix. Then in the stack, evaluation of the postfix expression using the stack, application of the stack function call, where we can use a stack function call. That all we are going to discuss about stack. Then coming to one more data structure, that is queue. The basic concepts of the queue, we are going to define what is queue. We are going to represent how queue will be represented in the computer main memory. And then types of queue, how many queues are there? Simple queue, circular queue, double-ended queue, priority queue and operations on the simple queue. What all the operations we can do on the simple queue. This all we are going to cover in unit 2. Next, see in the unit 3 what we are going to cover. We are going to discuss one more very important type of data structure, that is linked list. What is linked list? Definition and a representation of the linked list. Type of the linked list. Again in the type of the linked list we come across with a single linked list, double linked list, header linked list, circular linked list. Okay, these are all different types of linked list we are going to discuss. Representation of the linked list in computer main memory, memory operations. How we are going to represent the single linked list in computer memory, and what is the main concept of data structure? That is traversing, searching, insertion, deletion. These all operations what we are going to do on linked list, that we are going to discuss in regarding linked list. Then what we have is one more type of data structure, that is tree. We are going to define tree. What all the terminologies that comes in the tree. The terminologies that comes with the another data structure like array, stack, queue, linked list is little different what we are using the terminologies in the tree. So they are specifying that what terminologies we are using when we are dealing with the tree. That is node, what is root, node, what is parent node, who is the ancestors and who is the siblings. These are all some of the terminologies what we are going to deal with when we are dealing with the trees. Degree of the node, depth, how long it is, and path of the node, how it is traversing. That all comes under tree. Then most importantly, in the type of tree, binary tree is very important, that we are going to discuss about the operations on the binary tree. Type of binary tree, strict binary tree, complete binary tree, binary search tree and the heap tree. The array representation of the binary tree, traversal of binary tree, pre-order, in-order and post-order traversal is similar. Pre-order means before how it has to be ordered, first operator will come, and in order means operator will come in between, and post order means operator will come at the end. How we are going to traverse and execute that particular expression using a tree. This all we are going to study in the unit 3. Next what we have is marks distribution. Your marks distribution for internal, you have a 30 marks. Out of this 30 marks, for your first internal, we will be covering the topics from unit 1. First internal will be covering the topics from unit 1 for 30 marks. For the second internals, we will be covering the topics from unit 2 and unit 3. Together will carry 30 marks, and the final average or final your internal marks will be an average of your 2 internals. Okay, and what is the exam pattern? 60 marks. Out of 60 marks, from each module, you will be having part A and part B. In part A, what you will be having? From each module, one question or second question, question 3 or question 4, question 5 or question 6. From each module, you will be having 2 questions, out of which you have to answer 1 question, which will be carried for 15 marks, for 15 marks, for 15 marks. Totally, we have part A for 45 marks and part B for 15 marks. They will be given 5 questions, out of which you have to answer 3 questions. Each question will carry 5 marks. So, total marks will be for 15 in part B. 45 plus 15 marks will be having the final exam for 60 marks. Some of the reference book for this particular subjects are Data Structure Using C by Pearson publication, Introduction to Data Structure by Pearson publication, and then the Data Structure Using C by Katekar. Katekar is a local author who converted the foreign author book into the simpler way. Katekar book and Data Structure Using C by P.B. Kottu. These are some of the important books what you can refer for to better understanding on the subject. Thank you.